Hey, have you ever just stopped and thought about the incredible dance our planet is doing, like right now? Today, we're going to pull back the curtain on something we take for granted. We're talking about the spin, the orbit, the tilt, all the things that literally create our days, our years, and our seasons. And trust me, it's a story of discovery that pretty much changed everything for humanity.
I mean, think about it. For centuries, humanity was stumped by a super simple question. What is the shape of our world? It's something we teach kids in kindergarten, right? But for most of human history, it was this massive mystery. And finding the answer, well, it wasn't just about redrawing the maps. It was about redrawing our entire understanding of the universe and our little spot in it. So, before we got to the right answer, we had to get through some really interesting wrong ones. Let's start with the big one, the one everyone knows about, the idea that our world was totally flat. And you know what? It's not that crazy when you think about it. I mean, just look around you. From where we stand, the world looks flat, right? It just stretches out to the horizon. If you don't have spaceships or advanced math, a flat Earth is, honestly, it's the most logical conclusion. It was just common sense for hundreds and hundreds of years.
Oh, but it didn't stop there. The thinking went something like this. If the Earth is this big, flat, unmoving thing, then that shiny thing up in the sky, the sun, it must be the one doing all the moving around us. And that idea put humanity quite literally at the very center of the entire universe. Pretty cozy, huh?
But, curiosity is a powerful thing. People started looking closer. Astronomers, thinkers, they began to spot things that just didn't add up in this flat Earth model. Piece by piece, they were paving the way for a totally radical new vision of our planet. For ages, smart people had been figuring it out from little clues, like the shadows on the moon or how ships disappear over the horizon. But this picture, this was the final nail in the coffin for the flat Earth idea. This was the ultimate I told you so. The first time we saw our home from out there, all the arguments just stopped. There it was, a beautiful blue sphere just hanging in space.
So what are we looking at? A sphere. Basically a giant ball. Now, if you want to get technical, it's an oblate spheroid, which just means it's a little squished, slightly wider at the middle. But for our purposes, thinking of it as a huge ball is what's important. Because that shape, it's the foundation for everything we're about to talk about, from why we have a Tuesday to why it's cold in December.
Okay, so step 1. The Earth is a sphere. Check. Now for step 2, understanding how it moves. Let's start with the most basic movement, the one that defines our daily lives, its spin. This spinning movement has a name. It's called rotation. The easiest way to picture it is to imagine a huge invisible pole poked right through the middle of the Earth, from the North Pole all the way down to the South Pole. We call that its axis. And our planet is just constantly, endlessly spinning on that axis, kind of like a top.
And this constant turning is what gives our world its most basic rhythm. It takes about 24 hours to complete one full spin. And that, right there, is where we get our concept of a day. It's like the master clock for our entire planet.
And the result of all this spinning? It's actually super simple and really elegant. As our planet turns, one side faces the sun and gets all that light and warmth. We call that day. Meanwhile, the other side is facing away, into the darkness of space. That's night. It's this beautiful, continuous dance between light and dark that pretty much runs the show for every living thing here.
All right, so the Earth is spinning in place. Got it. But that's only half the story. At the very same time, it's on a much, much bigger journey. So let's zoom out a bit and look at our planet's year-long road trip through space. This bigger trip is called revolution. So while the Earth is rotating on its axis, it's also traveling along this huge fixed path, an orbit, all the way around the sun. So you've got two things happening at once. It's spinning like a top while also running a giant lap. It's a pretty good multitasker. And that one enormous lap around the sun, that's what defines our year. It takes about 365 days for the Earth to make it all the way back to its starting point. And that's the basis for our entire calendar. It's how we mark time on a much grander planetary scale. Okay, now we're getting to the really cool part. We've got the spin for day and night, and we've got the orbit for the year. But how do those two things work together to give us seasons? Spring, summer, autumn, and winter. The answer? It's a little trickier and a lot more interesting than you might think. So yeah, if the Earth is just going around the sun in a circle, why do we even have seasons? This is such a great question because it tackles a really common misconception. A lot of people think it's because sometimes we're closer to the sun and sometimes we're farther away, but that's actually not it at all.
The real reason is so much cooler. Okay, here's the secret ingredient. The Earth doesn't spin perfectly upright. It's tilted. The axis we talked about earlier, it's leaning over by about 23.5 degrees. Now, as our tilted planet makes its year-long journey around the sun, sometimes the northern half is leaning towards the sun. It gets more direct sunlight, and boom, that's summer. Then 6 months later, it's leaning away from the sun, getting less direct light, and that's our winter. The seasons aren't about distance. They're all about this planetary tilt.
And this tilt leads to some really wild effects, especially at the poles. Take the North Pole, for instance. At the peak of its summer, it's tilted so far towards the sun that the sun never actually sets. It just circles the horizon. They call it the midnight sun. Can you imagine? Sunshine at midnight?
And this isn't just a one-day thing. It plays out over the whole year. From around March to August, the North Pole gets 24/7 daylight, 6 straight months of sun. But then, as the Earth moves to the other side of its orbit, that same pole gets tilted away and is plunged into 6 straight months of total darkness. It's a world of extremes, and it's all because of that simple, steady tilt.
So, look how far we've come. We started with a flat, motionless world at the center of everything, and now we see a tilted, spinning globe on an epic journey around a star. This amazing cosmic dance, it isn't just some abstract science lesson. It's the rhythm of our actual lives. It makes you wonder, doesn't it? That simple daily shift from light to dark is a constant reminder that we're all just passengers on this incredible spaceship. What other amazing truths are hiding right there in plain sight?